Hello, everyone. We are Systemic Engineering, and we are doing the Mission Trails Pedestrian Bridge project. Here are our team members. I'm Richard. I'm the project manager and structural engineer. We have Yusuf A., the civil engineer, Fidel Martinez, the construction engineer, Abdul Wahab A., the environmental engineer, Yusuf A., the geotechnical engineer, and DeWitt Tekel, the hydraulics engineer. So a bit of introduction to this project. Our group was tasked with designing a pedestrian bridge that connects the north and south ends of the San Diego River crossing within Mission Trails Regional Park. And this is intended to be a memorial bridge built in honor of Max Lenial, who died while trying to cross the San Diego River during a flash flood. A bit of project background. Here's some images at the project site. You can see both where the river is dried up and where the river is flooded. And we are intending to build a bridge on the east side of where that river is on that bottom photo. Here are 6 studies that we completed in order to complete and design this bridge, and you will hear all about these within our project. First one up is civil.
As civil engineers, we're required to examine the sites before starting any type of project. So the important things to consider before starting the project is to study the location, either using ArcGIS, Google Earth, or a site visit. We will have to consider the site drainage as well. For this project, the bridge will be designed using wood, so it will not experience flooding. A site land grading is relevant as well because it will assure that the site has a high efficiency rate and a perfect smooth land will equal a better water drainage. Site slope using AutoCAD and site alignment is also important. A site inspection list will be necessary to assure that all project requirements are met. Here we navigated the mission trail location using ArcGIS. Here as well, we navigated the mission trail location using Google Earth.
For the structural study, we were given limitations for the bridge. The bridge could be no shorter than 80 feet, no wider than 8 feet, and had to be at least 3 feet higher than the 100-year flood elevation. And as per code, a pedestrian bridge constructed out of lumber must support a minimum of 90 pounds per square foot for regular usage by pedestrians and bicyclists. So when designing the bridge, this is the final design we've come up with. It's a very simple straight shot bridge across, completely made of wood, standing on wooden supports that are then supported by driven concrete piles. The assumed loading over the entire surface area of the bridge is 57.6 kilopounds, and structural calculations were performed using the SkySub software. A simple version of the bridge was created with supports and a uniform load, and calculations were conducted to test the success of the bridge under the loading conditions. And the next few diagrams will show the forces acting upon the bridge. Here's the simple model of the bridge. Here are the different reactions it experiences, as well as the axial stresses it'll experience, the shear stresses it would experience, and the moments that it would experience. The conclusion we came to is that we were provided info that the bridge would meet all of the structural requirements and would be successful. We also noted that the chance of buckling in the bridge was very low and could be considered negligible. The bridge is cost-effective and simple and meets all structural requirements needed to be successful in use.
During the construction of this project, there are a lot of environmental impacts that we need to be aware of. Constructing the pedestrian bridge in the middle of a natural park will negatively affect the surrounding environment. To avoid that impact, we need to take it into consideration and try our best to use eco-friendly tools and not ruin the trees, plants, and living species, etc. So here in this table, we could see the environmental impact analysis during the construction. We could see the impacts on the soil, flora, fauna, air quality, noise, aesthetics, human health and safety, waste management, and waste resource quality. Here we could also see another table of the impact analysis after construction. And here we did a study on the impact score for each category, and we can see that during construction the impact score is minus 4.5, and after construction the impact score would go up to 11, which is a good sign for the bridge to be good for the environment?
Hello, this one is hydraulic analysis for the site of the project. Flood control devices are constructed based on the net inflow from a catchment area. During the rise in temperature, some water will evaporate into a environment which needs to be accounted during sizing of flood control structure. Amount of water evaporate in transpiration process is relatively less, maybe not accounted generally in planning of flood control unless it is specifically asked for. Infiltration has significant effect on flood control planning as well. For site water control, I tried to design the bridge to be the flood stage of the river. When the bridge desk impacted by the flood water, it typically will fail. The bridge desk section during flooding is shown the bridge minimum 80 feet long. I assume the flood flow 14,500 CFS. The river across the section area at the bridge is rectangular due to the bridge abandonments and wind wells. This is I found the force of the lateral of the bridge on the flooding is 22,246.4 pounds per feet. I determined 100 years spill flood is used to design a bridge of the chance of the bridge not being flooded in the first 3 years of its lifespan time. 100 years peak flood is used to design the bridge of the chance, this one. I calculated due to the software crashed by the 100 years flooding through this one shows that 3% is flooding, but 97% is out of the flooding, as shows this one.
And for the geotechnical study, so the purpose of my part is the study to obtain and analyze existing soil parameters for the construction of the project. As my colleagues mentioned, the location is Mission Trail Regional Park at the San Diego River, and other purposes for my part is to review the types of soils of the site, grading, road access, and visibility. So here I showed the soil characteristics that will help us form this project. Also here I described the typical soil profile. And for the project site soil properties, we showed that granular soils are non-cohesive soils and have no shear strength. And if well consolidated and confined, they form a foundation that is almost as stable as rock. For the soil mitigation and conclusion, so we have 3 options that were considered as means of mitigating the effects of unsustainability of the project site. So sheet wall piling, backpiling, and soil stabilization. So in conclusion, it is recommended that the soil stabilization methods shall be utilized, and we need to add cement and lime to the soil to strengthen and stabilize sandy soil. So this is effective for multiple reasons. One of them is economical, simple, and environmentally friendly.
For this project, to determine the total cost of building a bridge, we looked into different sections. We looked at grading, landscaping, consulting services, and development impact phase. On the right side, you can see the image of how we divided the cost of the work. We determined that the total cost of work would be about $285,300.
Thank you for watching the presentation. We hope you've enjoyed. And with the studies and calculations and information that we've provided, we at Systemic Engineering hope that we've shown that our proposed improvements and mediation techniques for this project are feasible and adequately satisfy the project objectives. Thank you.